Let's take a look at how to graph a parabola that's in intercept form by hand. If you want to see how to graph this using a calculator, go back and watch my video for graphing in standard form. I showed how to enter these in and find the min or max using a calculator. However, this one I'm going to do by hand. The intercept form is fairly easy to do without a calculator. So your giveaway that you're in intercept form is you're going to see all your pieces multiplied together. There will be no plus or minus signs outside of the parentheses. Now there are going to be plus or minus signs inside, but that's okay. Every individual piece is being multiplied together. Sometimes I call this factored form because really this has been factored for us. So 3 easy steps to graphing these parabolas by hand. So first step is to find the x-intercepts. Your x-intercepts are going to be the numbers in the parentheses, but the opposite of those numbers. So my x-intercepts of this parabola are going to be -3 and +1. Now be careful, because some people find their 2 x-intercepts and they think they're supposed to put them together to make a coordinate, like -3, 1. That's not the case at all. They're both x values. We need x and y values together, not x and x values together. So what I'd recommend you do is, instead of just putting down -3 and 1, put down -3, 0, because that's actually the point, and then 1, 0. So those are the 2 x-intercepts, the 2 points this graph will cross the x-axis. So let's go ahead and actually graph those right away. To graph these by hand, I graph 3 points. So there's 2 of our points done already. Our third point, you can probably guess, is going to be our vertex, our other important point. So I've got the 2 x values, or the 2 x-intercepts figured out. My next step is to find the x-coordinate of the vertex. Well, because I know the 2 x-intercepts, I know the vertex is going to be symmetrical, or those points will be symmetrical. I know my vertex is going to be halfway between those, so I can kind of eyeball it and figure out that about right there is going to be where the middle is. But if I can't eyeball it, or if my values are not integers, or I just want to be more accurate, all I'm going to do is find the average of the 2 x-intercepts to find the middle. So your formula is to add your 2 x-intercepts together and divide by 2. Just basically, it's actually just finding the average. So that gets me -2 divided by 2, which gives me an x value of -1, which I can see from my graph when I eyeballed it, that's where I was. Now that's not where the vertex is, it just tells you where along this line the vertex is going to occur. So actually what we found already was the axis of symmetry. So I'll go ahead and label that axis of symmetry, and I'll label it also with its equation, x equal to -1. So I know my vertex is somewhere along that line. And for my last step, I'm going to go ahead and actually find the y value of the vertex. So to do that, I'm going to take my x value and plug it back into my equation to find the y, just like we've done before. So I've got 2 times, and then in parentheses, I'm going to plug in -1 for x, so -1 plus 3, and then -1 minus 1. Now, oops, too many negatives in there. -1 minus 1. At this point, people tend to make this really complicated, and they try to FOIL or do the box method to multiply or something weird. Just keep it simple. Just do order of operations. So order of operations says parentheses first. So let's simplify each parentheses, and I end up with this. And then just go ahead and multiply those 3 numbers together. 2 times 2 is 4, and then times the -2 is 8, -8. So those 2 values together, then the -1 we previously found and -8 is going to be my vertex. If you're really having a hard time with that step, you can just type it all in your calculator, but you should be able to do that by hand. That's not too bad. So my vertex is going to be down here at -8. There's the 3 points I need to graph this, so let's make a smooth U-shaped curve. Just kind of missed that point. Include some arrows, because this goes on forever. Make the parabola as rounded at the bottom as possible, and there's going to be our parabola graph in intercept form. Now notice, we didn't talk about the a value this time, but I can see that it all still checks out. Like our a value was positive, I can see this parabola opens upwards. So all those old tricks and rules still apply. This parabola is also in intercept form since everything's been multiplied together. There's no plus or minus signs, there's nothing being added or subtracted. Finding your 2 x-intercepts, though some people have a hard time finding the second one. They get that 4 is a solution in intercept. I'm going to write that as 4, 0, but they're not sure what to do with that x value. Well, if there's ever an x by itself, 0 is just going to be a solution. So 0, 0 is going to be our other x-intercept when you have x by itself like that. So let's go ahead and get those 2 points plotted. That's where my parabola will cross the x-axis. my vertex will be halfway in between those, so I know it should be at 2 just by eyeballing it. I can see that's the halfway point. Otherwise, remember your formula was to find the average of your x-intercepts. So 4 plus 0 divided by 2 is just going to be 2. So we saw that that was the case. That's actually where our axis of symmetry is. So I'll go ahead and draw that dashed line through there. And then finally, to find the y value of your vertex, go back and plug in 2 into your equation. So I've got -1/2 times 2, and then times 2 minus 4. If you want to type that all in a calculator at once, you can. Otherwise, it's pretty easy to solve by hand. -2 times 2 is -1. And then in the parentheses here, I've got -2 once I subtract that, which is going to work out to be just a +2. So putting those values together, I get my vertex at 2, 2. I can plot that point, and I see that my parabola must be opening downwards. I could check my equation and make sure my a value was negative, so it all checks out. But there is going to be a graph of my parabola. And finally, let's finish with a story problem that is written in intercept form. I know it's in intercept form because I've got everything being multiplied together, including that individual x. The question again may seem difficult, but like our last video, if you watch that one, the story problems are actually pretty easy as long as you understand how the form works. So in this case, we have a parabola that is modeling the path of a football. So x is how far the ball is thrown, and then y is how high the ball is thrown. So I'm actually going to just make a quick sketch of this so I can get an idea of what's going on with this parabola. So my two x-intercepts, one of them is going to be at 0. That's that x by itself. The other x-intercept is going to be at 46. So I've got a football that's starting from 0 on the ground. So maybe I'm not throwing it, maybe I'm punting it. And then it's landing on the ground at 46 yards. So if I kind of sketch that in, that's going to be the path that the football takes. So the first question then, if I look at my graph, actually kind of answers itself. It says, how far was the football thrown? Well, if I went from 0 yards to 46 yards, I threw that football 46 yards. I can see that from my graph. That's the 2 spots the football was on the ground. The next question is, what's the ball's maximum height? Well, I want you to ask yourself, where along that 46-yard path would the ball be at its highest point? And assuming there's no wind and nothing else going on, it's going to occur right there at the halfway point. Just like our graphs we just took a look at, it's the halfway point between 0 and 46 is 23 yards. So that's where the football will be at its highest point, but that's not actually the highest point of the football. To do that, we want to find the y value, the y value of the vertex, the maximum value. So like we did previously, let's go ahead and plug our 23 in for x. So my equation was that -0.026 times the x value, which we're going to use 23. That's the halfway point where the ball would be at its highest point, and plug 23 in for both x's. Now I would definitely want to use a calculator to multiply that out. I don't want to do that by hand. So doing a little calculation, I come up with a height of about 13.754, and then this was in yards. So plugging my x value in, I get my maximum height of about 13.7 yards.